Hello everyone, welcome back. In this session, we are going to look at the traveling salesman problem and make a solution to solve it using dynamic programming. So, starting with the introduction, I hope most of you know what a traveling salesman problem is, but I'm just going to quickly explain it. Let's say there are a list of cities from 1 to n. And there is a salesman who needs to visit all these cities, and he will start from one city, touches every city only once, and come back to the original city. That is the problem. So if the salesman starts from, let's say we have three cities, then the salesman needs to go, let's say from A, he goes to B, then he goes to C, and then he comes back to A. The condition is the path has to be minimum. So we need a sequence which generates the minimum path length. So it could be from A to C, then B, and then A. Or it could be A to B to C and then A. And we need to find the minimum out of these two combinations. So let's say we have a set of cities, and let's say we want to start from 1 and want to go to some city out of n cities, and let's say the last city we want to visit is J. And by visiting this combination, we are going to get the minimum path. So we are going to describe it as cost of our set and visiting the last city. Now let's say the person visits the last city J, and definitely after that he is going to visit 1, which means he is going to come back to 1. So then cost of this would be going from one to J plus distance of J to 1. Now let's say just before visiting J, there might be some number of cities. So and he chooses a city I. So then this means he will go from 1 to I and then from I to J. Or by making it like this, we say the salesman went to I from 1, and then from I he went to J. So this means we can say is going to be cost of our set which does not have J and going to I plus distance of I to J. So this is our cost of this whole thing and plus distance of this, right? So that's how we are going to build the recurrence for traveling salesman problem. And if we want to generalize this, then this is going to be minimum of cost of and removing t from the set going to I plus distance of I. So this is going to be our general recurrence for solving the traveling salesman problem using dynamic programming. Now this looks good. Now let's take an example which will make things more clear. So let's say we have a
4x4 graph. These are the cities, and
diagonal is going to be infinity because we don't want to start from city 1 and come back to city 1. So that's why we are going to take this as infinity, and then we have so looking at this recurrence, we see that we are going to create sets which is represented by j. So initially, let's say we take out j from the set of cities, but let's say at the next step we say that we choose some cities which are going to I, and we decided that I to k is going to be the minimum length. So this is going to be 1 to k and then k to I and then I to j, right? So this means what we actually are doing is we want to go to I out of different sets of p, q and k and decide which one is the smallest. And similarly for other. So then this is our set, and for every set we are going to decide a value of I which will remain same. So this means if we want to go to I and k, then k is going to be the then I is going to be the constant value. Let's see this using an example which will make things more clear. So let's say initially our set has one node, and when we say our set has one node, it can be 2 or 3 or 4, and because we started from 1 we are coming back to 1. So this means we can go from 2 to 1, 3 to 1 and 4 to 1. And so the cost of going from 2, which is our set, and we don't have a j, and we want to go to I, is equal to cost of distance of 2I, which is 10. Similarly, going from 3 to 1 is distance of 1, which is 15, and cost of 1 is distance from 4 to 1, which is 20. Okay, 4 to 1 is 20, 3 to 1 is 15, and 2 to 1 is 10. Okay. Now, let's say we want to now calculate when set has two values. So when set has two values, the values can be either 2, 3, 2, 4, or 3, 4. And for this set, our I can be 2, 3. So when our I is, for different values of I, when I is equal to 2, I is equal to 3, and I is equal to 4. This means when my I is 2, this means the intermediate city is 1, going from 1 to 2, and there could be multiple cities in between. But then intermediate city is 3 and the end city is 1, then we can have 3 here, we can have 4 here. Similarly, for this, there could be multiple cities, but our intermediate city I is equal to 3, and from 3 either we can go to 2 or we can go to 4, and then we can go to 1. Similarly, for this, intermediate city is 4, we can go to 3, we can go to 2 or 3, and then we can go to 1. So writing this, we can say from 2, which is our intermediate city, and
is cost of 3, 1 plus distance of 2, 3, which is similarly this cost of
2, 4 is 25. Now writing the same thing for when we want to go from the intermediate city 3 to 2 or to 4, which is cost of
which is cost of
2 comma 1 plus distance of 3 comma 2, which is 10 to 1 is 10 and distance of 3 to is 35. And the next is from 3 to 4 comma 1 is equal to cost of 4 comma 1 plus distance of 3 comma 4, which is 20 plus 30 is equal to 50. Doing the last one, when the intermediate city is 4, we are going to get 4 1, which is cost of 2 comma 1 plus distance of 4 comma 2, which is 10 plus 25 equal to 30, and from 4 to 3 to 1, which is cost of
3 1 plus distance of 4 comma 3, which is 3 1 is 15 plus distance of 4 3 is 30, which is 45. So if we look at this
is 4 comma 3, 4 to 3 to 1, and this is 4 to 2 to 1. This is 3 to 2 to 1, and this is 3 to 4 to 1. Then this is the intermediate city is 2, 2 to 3 to 1, and this is 2 to 4 to 1. Okay. Now, when our set has 3 cities, then what is going to happen? So then 3 cities means we can have 2 comma 3 comma 4, but we need to decide what is going to be the value of I. So if our I is 2, then we can go from 3 to 4 to 1, or if our value of I is 3, then we can go from 2 or 4. We really don't know if we are going to go from 2 or going from 4, which will depend on the minimum path, which could be 3 to 2 or 3 to 4, and then we go to 1. Similarly, if our I is 4, then we can go from either 2 to 3, 2 or 3 to 1. This means we are going to write this as one, which is minimum of going to 2 to 3 and then 3 to 4 and then 4 to 1, right? Or going from 2 to 4 and then 4 to 3 and then 3 to 1. So we will write and going from 3 to 4 to 1 is 3 to 4 to 1 is 50 plus distance of 2 and 3 is 35, which is 85. And this is the path when we do 2 to 3 to 4 to 1. And then if we go from,
then this is going to be cost of plus distance of,
which is going from 431 is 45 plus distance of 24 is 25, which is 70. So our minimum is this. Same way we are going to do when our intermediate city is 3 and we want to go from either 2 or 4, but we don't know if we go 3 to 2 to 4 or we go 3 to 4 to 2, which we are going to calculate. So this will be to 4 to 1 plus distance of 3 to 2, which will be 241 is 45 and distance of 3 2 is 35, which is 80. So this is the path 3 to 2 to 4 to 1, and then we want to calculate this path, which will be 4 to 2 and distance of 3 to 4, which is 35 plus 30 is equal to 65. So our minimum is this here, our minimum is this here. Now the last one, when our intermediate city is 4, then we can go from 4 and 2 and 3. So this means we are going from 4 and passing 2 and 3, but we don't know in which sequence we are going to pass, and it is going to depend on which one is the minimum value for the different options or the different combination of paths. So this is going to be cost from 2 to 3 and distance of 4 comma 2, which is 50 plus 25 is equal to 75. So 231 is 50. So 231 is 50, and then distance from 4 to 2 is 25. Similarly, if from 4 we go to 3 instead, so then cost of 3 to 1 is 45 and distance of 4 3 is 30, which is 75. So because both are Same, we can randomly pick any of them. So this means these are the path from going from 4 to 2 to 3 to 1 and 4 to 3 to 2 and okay, fine. Now the last leg is when our set has all the cities. This means we will have 1, 2, 3 and 4, and the last one is 1 again. So, and we know we are going from 1. So this means we go from 1, and similarly like the previous one, but we don't know from 1 are we going to 2 or going to 3 or going to 4. Okay. So let's say from 1 we go to 2, then it will be 3 and 4, 1. Or if we go to 3, then this will be 2, 4, 1. And if it is 4, then it will be 2, 3 and 1. So we have already calculated these values in our previous iteration, which is, if you see, we have already done that. So the minimum values are going to come from this. We just need a distance from 1 to 2, 1 to 3 and 1 to 4. So how are we going to write this? We are going to write it like cost of 1, 2, 3, 4 and then 1 is equal to minimum of cost of, let's say we go from 1 to 2, so then this will be 2, 3, 4 and 1 plus distance of 1, which is 75 plus 10 is equal to 85, and this path is 1 to 2 to 1 to 2 and then 3 to 4 and 1. Second, if we decide we want to go from 1 to 3, then it will be this and distance of 1, 3, which is, so now this is coming from previous iteration 3, 2, 4, 1, 3, 2, 4, 1, and the minimum is 65. So this will be 65 and distance of 1, 3 is 10, which is 75. Same, if we decide to go to 4 from 1, then it will be plus distance of 1, 4. So 4, 3, 2, 1 is, the minimum is 75. So this is 75 plus 1, 4 is
1, 4 is 20. Which is 95. So
the minimum is, then this is going from 1 to 3 and between 2 and 4 to 1, and this is going from 1 to 4, and then between 2 and 3 to, and we see our minimum path is coming out to be 75. So this is, the cost is 75, and which is from 1 to 3 to between 2 and 4 we took this path, which is 3 4 2 1. So this is our path for the traveling salesman, and this is going to be the optimal path, going from 1 to 3 to 4 to 1 and coming back to 1, and this is going to take a cost of 75. And this finishes the solution to the traveling salesman problem using dynamic programming. I hope this was informative for everyone. I suggest you watch it a couple of times and try to practice a couple of problems so that you have a good understanding and hands-on of solving this problem. Thanks for watching, and bye for now.